Hey guys, good evening. Greeting you is your teacher, Mr. Phakathi from Ntsinini High School. Wonderful geographers. Today we are going to do a topic on river systems. I'm going to show it on screen here so that you may be able to follow along and you'll be able to take some notes. Here is our topic, river systems and introduction. We are introducing river systems. So in this introduction, we'll cover 5 objectives. The first objective is to define technical terms that you will come across in the topic of river systems, and that possibly examiners can ask you to define those terms. Please pay attention to them. And the second objective is to describe a river profile and types of river valleys. The third objective is to describe the work that a river does from the upper stage through the middle stage down to the lower stage or towards the end of the river. And the 4 is to describe the processes of river erosion. The processes of river erosion. How does a river erode its load? Then the last objective, we are going to describe the processes through which a river transports its load. Okay, all right. I hope you are ready. Let's go through the first objective, definition of technical terms. We have this term here, river. What is a river? Is a body of water flowing over the land in a defined, it should be defined in a defined, sorry about that, in a defined channel from a source to the mouth. Source where the river begins, mouth where the river ends. Then we said the river is, the water flows in a channel. The water flows in a channel. What is channel? It is the part of land in which the water of a river flows. Okay, that's a channel where the river flows. Then the source, of course, is the place where the river begins. The mouth here, the mouth, it is where the river flows into the sea or lake. So the mouth is at the end of the river where the river enters a larger body like a sea or like a lake. Then we have river system. What is a river system? Streams and rivers that join together. Streams and rivers that join together. That is river system. Okay. Then we've got permeable rock. Permeable rock, it's a rock through which water can pass. So it's a rock that has got some pores, so water can pass through that rock. It's a permeable, a rock that allows water to pass through. And the opposite is impermeable. The opposite is impermeable rock. And then overland flow is water that runs over the land in a sheet, not in individual channels. So it's water that is just flowing on the land. It is called overland flow. Then sheet flow is surface runoff, water that flows on the surface. Then undermining is the undercutting of the banks by the force of the water. It happens in waterfalls. The water is undercutting of the banks of the river. Then there's load. What is a river load? It's a material eroded by the river and carried in the water. The water, it could be rocks, mainly it's rocks that are deposited into the river and are being eroded. Velocity, it means the speed of water flow, the speed of water flow. Wetted perimeter, it is the sides, that is the two banks, and the bed of the river channel that the water is in contact. Then carrying capacity is the amount of load. So carrying capacity is the amount of load transported in relation to the river's velocity and volume. So these are the terms. We also have terms like tributary. Those are small streams joining a main river. So small streams that join a main river is called tributary. Okay. We also have a confluence. Confluence is a point where a stream joins another. It's a confluence where the point where two streams join each other, it's a confluence. So that's another definition that you should know. And then the second objective, now that we are done with the definitions, is to describe a river profile and types of a river valley. Okay, we will begin with the profile. We'll begin with the profile. There are two types of river profile. There are two types. We have longitudinal, as you can see, that's the spelling, longitudinal profile, and we have cross profiles. Okay. Let us begin with the longitudinal profile, or sometimes it's mostly called long profile. The longitudinal profile is this one here. Look at the diagram here. The profile is showing the distance traveled by the stream or river from its source. The source is somewhere here. It's flowing in three different stages from its source here. The first stage is separated by this dotted line. This is the first stage, which is the upper stage or the youthful stage of the stream, which is more steep. This stage, the gradient is very steep, so the stream takes a steep shape. And then as you come to the middle here, it's beginning to be gentle. This is the middle stage. And then we have the old stage or the lower stage at the end, the third one here, which is very gentle. When looking at the whole shape of the longitudinal, the whole shape of the longitudinal, you can see that it takes this shape, concave. It's a concave shape. The longitudinal takes a concave shape from the source of the river down to the mouth. The mouth is here where the river enters the larger body, which is the sea. So this is the longitudinal profile. Okay, and these are the characteristics in the first stage. In the first stage, we've got vertical erosion, where hydraulic action, abrasion, attrition, we'll talk about this. They are dominant processes. Traction and saltation is the dominant process of transporting material here, because they are heavy. They are heavy. That's why it's traction and saltation. The load in this stage is very heavy. The size is large and more angular. It's large. That's why the transportation is traction and saltation. And there is a V-shaped valley. The shape of the valley is V-shaped in this stage of the longitudinal. And then the Egcse stage. Here are the characteristics here. The channel is deeper and wider. There is vertical erosion is decreasing. Vertical erosion is decreasing because the vertical erosion is dominant in this first stage. In the Egcse stage, the vertical is decreasing. The increasing erosion is lateral, which is eroding the sides of it's eroding the banks here. The banks here, I hope you can see the banks are being eroded. Yet in the first stage, the deposition is going down instead of sideways. It's going down. That's why it's called vertical. It's going down. But here it's going sideways. It's lateral. Okay. The load is becoming smaller in size and is becoming less angular in shape because of the erosion. The load is continuously being eroded as it is transported from this stage to this stage. I hope you are following that. And then this last stage, the lower stage of the long profile. Here are the characteristics of this stage. The channel is at its widest and deepest and may be tidal. So here the channel of the stream, as you can see, is very wide, open. The banks have been eroded sideways. They've been pushed further by lateral erosion, and now it has open wide banks or channel, and there is deposition now that is taking place. There's a lot of deposition in this stage, and the size of the material is now fine. The material, the load has been further eroded. It has been further eroded. A large amount of the load, but the size is very small and very rounded. You must understand that. The load size very small, but in large amount, and also is now more rounded because it is being eroded. Okay, so that is the longitudinal. Then the second profile, we said, is the cross profile, or we normally know it as cross section. The cross profile is the profile that is showing us the view of the stream across from this bank to this bank. So here we are looking at a view when you cross a stream at a particular point from this bank to the other side. We have a cross profile that is having a V-shaped, is found, as we have said here in the longitudinal, it is found in the upper stage of the stream. It is found at the upper reaches of the stream or of a river. It's a V-shaped cross profile, okay? Because the erosion is vertical. The bed is being eroded, digging deeper the channel, okay? And then here, the second profile, cross profile, is this one, which is an open V. It's an open V, okay? It's an open V. It's becoming more of a U-shaped valley. It's becoming of a U-shaped profile, which means the sides here are being eroded by lateral erosion. So the V is beginning to open up, and then the last cross, the V has been further opened to form a wide open U, that is in the lower stage of the stream. So that is those are the two profiles that you should know, the longitudinal, okay, and then the cross. Cross, we have V, we have an open V, we have an open U, okay. All right, so those are the profiles. Okay, let me hold on here so that you just take some notes. These are further characteristics of a longitudinal profile. Maybe let me just increase it for you so that you can copy the notes, okay? These are the characteristics. Okay, you'll be guided by these solid lines here. The information on the left of this black line are characteristics of a longitudinal profile in the upper stage, that is upper stage or upper course. And these characteristics here are in the middle stage here. And then in the lower stage, you will have these characteristics over here. Okay, and we still have more of the characteristics of a longitudinal profile. In this case, we are shown even more characteristics when looking at this diagram. In the upper stage, the stream is very narrow, you see that, and is more straight, There are few meanders in the stream. It's narrow and more straight. But as you approach the middle stage, the stream, the channel is becoming wide and is having what? Some more meanders, looping meanders, large loops of meanders. And then you go to the lower stage, the channel size, it's more wide, as you are going to the mouth. So those are the characteristics, further characteristics. And here it's a summary of the characteristics, Just take them for your own information. And then let me just enlarge here so that you can see this cross profile. I want you to see well this cross profile here, this one. You are given more characteristics on the cross, the upper stage, that's the V, the open V, and the open U in the lower stage. So here are the more characteristics of the cross profile. All right, thank you guys. Let's move on to types of river valleys. We were talking about profiles, longitudinal and cross. Now, what are the types of valleys? I have been mentioning the valleys as I was discussing, as I was presenting the profiles. But to be precise, we have a valley. Okay, a valley is a low area of land between hills or mountains, typically with a river or stream flowing through it. We have the first valley, the V-shaped, as we've been saying. V-shaped valleys are valleys formed by rivers. They have a V-shaped cross-section and very steep sides. The sides are steep, as you can see. This is a V, the sides here, very steep, very steep. These valleys are usually found near the source of the river due to the presence of steeper bank. However, they can also be formed downstream. V-shaped valleys are formed by erosion. Which type of erosion? The vertical erosion. The river carries stones and rocks in its water. The force of the water and the grinding of rocks and stones cut down into the river bed to carve out a valley. Over time, the valley becomes deeper and wider. As you can see, over time, it's going deep, but it's also growing wide, as you can see here. Then as it grows wide, it leads us to the second valley, which is the U-shaped valley. The U-shaped, it is when the V has been opened wide by the erosion, as the river erodes the sides here, the banks, okay? So a U-shaped valley is the shape left after a valley has been deepened by a glacier. What do we mean by glacier? Slowly moving mass of river of ice. Okay, so the original V-shaped valley, which would have been made by a river, is widened and deepened after the ice has eroded the sides of the bottom of the river. Like you can see here, this was a V, but because of the glacier, the flow of glacier, the V has been opened this way. It has now formed this U. As you can see, it's a U-shaped valley. As the U-shaped is being eroded, a flat floored valley is formed. A flat floored valley is formed. The flow here is flat. The third type of valley is called a flat floor valley and is the most common type in the world. These valleys, like V-shaped valleys, are formed by streams, but they are usually older. Why do you say older? Because they are formed when the U has been further eroded, opened, as the slope of stream's channel becomes smooth and begins to smooth the steep V or U shape. It is being smoothened. It becomes smooth at the bottom here to form a flat flowed river. Example is the River Nile. The River Nile. Here is a photograph of the River Nile. It is having the flat flowed valley. Then there is also a valley which is called a rift. A rift is a valley that forms where the earth's crust is spreading. You remember in JC you did what is called faulting. Faulting causes the crust to spread or split apart. When there is a splitting apart of the crust of the earth, this kind of valley is often formed. It is very narrow with very steep sides and flat top. As you see here, the top flat, but look at the sides. Very steep, very steep, very steep, very steep, okay? And many rift valleys have been found underwater along the large ridges that run throughout the ocean. These ocean ridges are formed as tectonic plates move away from each other. Here is an example of the convergence of the plates. Here, you can see this fault line here, the separation, which means this side is being pushed this way and the sides of the line of the crack is pushed that way. It forms it has formed this valley right here. Okay, so those are the valleys that you may have, that you have to know about rivers. Then the third objective is describing the work of a river. What work does the river do? There are three types of works of a river. Three. The first work of a river is erosion. The river erodes its course to develop its channel. So to develop its channel, it has to erode it. Erode the channel itself. Erode the channel itself. It has to erode the channel. How the channel is being eroded? There are three ways the channel of a river is being eroded. The first one is called headward erosion. This one, it is when the river is eroded in its mouth. Let me just say it like that. It is being eroded in its mouth upstream, from the mouth upward. So this is going to increase the length, okay? Because if the stream was having a mouth here at this point, let's say the stream had its mouth here at the, you see that? And then this is up, this is downstream. If this is upward, this is down, then we say headward. The stream is being eroded this way. When you go up like this, you see the size is doing what? Increasing. Now the stream is from here to here. Okay. The second way the river erodes its channel is vertical. We talked about it. It erodes the bed, making the channel to be deep. Then the last one is lateral it erodes the sides, the walls, the banks themselves, making the channel to become more open or more wide. So those are the three ways the river erodes its channel. Then the second work of a river. Remember, the first work we said is what? We said is the erosion. Then the second work of a river is transportation. Transportation. Okay, ladies and gentlemen, good geographers. Transportation, the river transport the different sizes of its load. When erosion of the channel happens, there will be particles that are being deposited into the stream. They are called load. So the river now transports the load from its upper stage. At the upper stage, the size of the load is large. The shape is angular or irregular. But now, as you move to the middle stage, the size is becoming small and the shape is becoming more rounded. It's the angular shape is being reduced. Okay, that is in transportation. Then the third and last work of a river is deposition. A river erodes, transport what has been eroded, but at the lower stage where the energy to erode and to transport has been reduced, the river lacks the energy now. It begins to deposit the many small and more rounded load. That is what happens in the lower stage. Deposition takes place. Okay, ladies and gentlemen, I hope you are still following and catching up. Let's move on to describing the processes of river erosion. Please don't be confused. Somebody will say, we're talking about erosion again. Here, we talked about 3 ways a river erodes the channel. All right? When the channel is being eroded, there will be deposits that are dropping into the river, which is called the load. Now, the load of the river will be eroded. There are processes that will erode the load of a stream. Here are the processes in this diagram. We have a process called attrition. The particles, as you can see them, the load is being eroded through a process called attrition. There is also erosion process called hydraulic action. The load of the stream can be eroded through a process called hydraulic action. Another load or the same load can further be eroded, or basically, if we put it in arrangement, we can start from here. The abrasion is the first, the biggest load is eroded through abrasion. Then the second one will be hydraulic action. And of course, attrition will further erode the load. As the load is being eroded, you see what is happening. The size is being reduced. The size is being reduced. We started from here, we moved to here, we moved to here. And solution, you can't see anything now. The size is the load has been converted into a solution. What is hydraulic action? This is when the load, this is when the load is splashing the water. Let me put it like, the water splashes the load, the particles on the walls of the banks, or it is the water is splashing hard against the walls of the banks. Okay, so even air becomes trapped in the cracks of this river bank and bed and causes the rock to break apart. It breaks the rocks apart as the water splashes hard on the walls. The loose rocks will be eroded, will be removed from the wall, Okay, I hope you understand that one. Then the second one is abrasion, which is also called corrosion. The spelling, please don't come, you must master the spelling. Abrasion is also called corrosion. It is when the big load grind along the river bank and bed in sand, peppering effect. It's like it's scrubbing on the bed, scrubbing on the walls. That is abrasion. They are scrubbing. As they scrub on the banks, on the bed, they are being reduced in size and the shape is being smoothened as well. Okay? Then there is attrition. Attrition, the rocks that the river is carrying knock against each other. They hit against each other. They knock against each other. As they do, they break apart and become smaller and rounded in size as well. And the last process through which the river load is eroded is solution, which is also known as corrosion. It's solution or corrosion. It is when the water dissolves certain types of rocks, such as limestone. Okay, so soluble parts of the rock are being dissolved and it is going to be transported, the size will be reduced into very finer ones. Okay, and then the last objective here, ladies and gentlemen, is describing the process of river transportation, okay? The process of river transportation. There are 4 processes of river transportation. There is this one. I will start with the one that transports heavy load. Is called traction. Okay. It carries heavy load. Then the second load that is less heavy but still big is called saltation. And then small light load is transported through a process called suspension. And then the final ones, it's solution. So these are the 4 processes through which a river transport its load. You can see the diagram here. It means that traction, the load is big in size. It is being pulled along the bed. As you can see these arrows here, they are just pulled along the bed, dragged, if I may use that word, the correct word. The heavy load is being dragged on the bed, as you can see these arrows. And then saltation, look at the arrows. The load is bouncing up and down, bouncing up and down, bouncing up and down as it is transported downstream. Okay, so this stream is flowing this way. Looking at the arrow, the arrows are showing the flow. It's going this way. So here, traction dragged along, but saltation bounce up and down, up and down, up and down. As they bounce up and down, they are moving downstream. Then we have suspension. In suspension, light river load is floating on the surface of the water. It floats, like you say here, say fine light material is carried along in the water. It floats on the surface. It floats on the surface. But then solution, it is when minerals that dissolves in water are dissolved and are carried as what? As solution. So these are the 4 processes through which a river can transport its load. Thank you very much, ladies and gentlemen. This marks the end of our lesson. I love you and I am always caring about you guys. Please do not be confused. Focus into your studies. Study very hard. You must know that regardless of the situations that we are going through as a country, as the world, you know, and the disturbances that you have been going through, please don't give up. Don't give up. All these challenges cannot determine your success. It is only your determination, your commitment, your focus that will make you succeed regardless of all these situations that are going on. Thank you so much. Be blessed and be cool as you master this lesson. Thank you. I'll meet you in our next lesson on river systems. Okay.